This is the Chapter 7 test review. I'm going to do the left-hand side on this video, and the right-hand side is your homework. There will be a key posted. First thing, we have some ratio problems. It says a train is 10 feet and a model of the train is 10 inches long. What is the ratio of the length of the model to the length of the car? So a few things to be careful about, a few things that people will do incorrectly and lose some points. Okay, first, make sure that your units are the same. So this one is 10 feet, this one is 10 inches. We have to make sure that we take care of that. So the easiest thing to do is take the bigger unit, 10 feet, and multiply it by 12 because there's 12 inches in 1 foot. Okay? So what that does is that gives us the feet unit cancels out. We have 120 inches. Now we have inches to inches. Okay, the second thing to be careful about, which way do we want to go? Okay, do we want to go the model to the car or the car to the model? And that comes from reading the problem. What is the length of the model to the length of the car? So we're going to do the model first, the car second. Okay, then last thing you have to make sure you do is reduce. So what we have, the length of the model is 10 inches. The length of the car is 120 inches, and that just has to be reduced. They both end in a 0, so you can divide by 10. So 1 to 12 is that ratio. Okay, next. The Knowledge Bowl team had 76 matches. They gave us a total. Their win-to-loss ratio is 11 to 8. How many matches have they lost? The first thing I put up there is that they had a total of 76 matches. And that total just comes from the problem. Okay, some of those were wins, and some of those were losses. Okay, so the number that they win plus the number that they lose adds up to 76. Okay, this ratio that they gave, okay, is 11 to 8. So what we do is we add x's to those. 11 is going with the wins. That's the first number. So we have 11x for the wins. We have 8x for the losses. Those total up to 76. Okay, we solve this for x. That gives us 19x equal to 76, and we divide by 19. What this gives us is an x value. X is 8. That's not our answer, because what we want to know is how many that they lost. Oops, I'm sorry, not x equals 8. X equals 4. Bad math from the math teacher. All right, so 76 divided by 19. That's x equals 4. Okay, from there, that's not our answer. The question was, how many matches have they lost? Okay, this is what we're trying to solve. So we need to take that and multiply it back into the loss part of the ratio, which is 8 times x. So the number of losses equals 8 times x is 4, which is 32. Third problem is cross multiplying. So we have the means and the extremes. The extremes are 5 and 9.5. The means are x and 7.5. So we have 5 times 9.5 equal to 7.5 times x. Okay, 5 times 9.5 gives you 47.5. Equal to 7.5x. We divide both sides by 7.5. Okay, out of space here, but that gives us that x is equal to about 6.3. 47.5 divided by 7.5. Okay, it can be a little trickier if there's just distribution. So in this one, okay, the extremes are 2x minus 1 and 4. So we have 4 times parentheses 2x minus 1 equal to 3 times parentheses x minus 4. Make sure that these get distributed. We have 8x minus 4 equal to 3x minus 12. Okay, I would subtract and get the x's on the same side. Okay, and then I would we have 5x minus 4 equal to negative 12. Add 4 to both sides. And we have 5x equals negative 8. So when we divide by 5, this is a good enough answer for x. Negative 8 over 5, okay, or negative 1.6 is another good answer. Okay, last one on the front here for the left-hand side of the page, the measures of two complementary angles. So that means 90. Complementary means 90 are in the ratio of 7 to 11. What is the measure of the smaller angle? Remember, we add x's to these ratios. So our ratio is 7x to 11x. Okay, and then remember, we're going to plug it into the smaller one after. Okay, so what we have is 7x plus 11x needs to make 90. That's what complementary means. This is 18x equal to 90. Divide by 18, x is 5. Not our answer. Okay, we want the smaller angle. The smaller angle will go with the 7. So for the smaller angle, okay, what we're looking at is 7 times 5. So 35 degrees. So the ratio word problems, they give you a total and they give you a ratio. Add x's to the ratio, set it equal to the total. Okay, that's it for the first page. Page 2. Okay, the ways that you can move around some proportions. Okay, they're going to give you a proportion to begin with. Okay, there's 3 different properties to know to complete each statement. So, first thing they have here is they did, instead of x over y, now it's an x over 5. So that's what moved. Okay, so one of the properties is you can switch the means. So if the 5 replaced the y is going to go back where the 5 was. So y over 7. Okay, this one is flipped. Instead of x over y, now it says y over x. So this one was flipped. So we're going to flip the second one. Instead of 5 over 7, it's 7 over 5. Okay, the last one is adding the bottom to the top. So they did x plus y over y instead of x over y. So what we need to do here is 5 plus 7 over 7. And if you wanted to write that as 12 over 7, you sure could. Okay, next, quadratic formula. Okay, first thing to do with quadratic formula, A is 2, B is 9, C is negative 5. Okay, maybe we should write down what the formula is. Not something that you'll need to have memorized because we have note cards on tests. Okay, so we have what we need. We're going to go to the plug-in step. X is equal to negative b. That's the opposite of b, so negative 9 plus or minus the square root of b squared, which is 9 squared, minus 4 times a is 2, c is negative 5. All of this is over 2a, which is 2 times 2. Okay, next step, we have negative 9 plus or minus the square root. This is 81. Be careful here, we have a negative 4 and a negative 5, and a negative times a negative is a positive. So this is plus 40. 4 times 2 times 5. Okay, all this is over 4. So this is equal to negative 9 plus or minus the square root of 121 over 4. Okay, and 121 is a perfect square. So what we get, negative 9 plus or minus 11 over 4, and we split this into 2 answers. Okay, we have negative 9 plus 11 over 4, which is 2 over 4, which is 1/2, 0.5. Okay, we have negative 9 minus 11 over 4, which is negative 20 over 4, which is negative 5. Those are my 2 answers. Okay, geometric mean, okay, they're going to give you 2 numbers. Those are the extremes, okay. There's a formula that you can use for it, or you can set up the proportion, okay. The proportion here, okay, is 2 over x equals x over 12, okay. What's going to happen here every time, we're going to cross multiply. We're going to get x squared equals 2 times 12, which is 24, and then we're going to take the square root. Okay, so if that way makes sense, so we're not allowed to use decimals for this. So we have square root of 4, square root of 6. Okay, perfect square, the biggest perfect square that goes into 24 is 4. So the answer here is 2 square root of 6. Okay. There's a formula that can get you there. What we're always going to have in that second step is we're going to be taking a square root of something. And what we're taking the square root of is just the two numbers multiplied. So you can just go right to a formula if you want. Okay, so for example, okay, a and b are just the two numbers they give you. So this is the square root of a times b, which is the square root of 16 times 4, which is the square root of 64, which is 8. So there's a formula for geometric mean. You can also just set up the proportion. So if the proportion makes more sense, awesome. If the formula makes more sense, that's great too. Okay, so let's just do it the proportion way one more time. Okay, the means match. What we're doing is x squared equal to 8 times 32, which is 256. Take the square root of both sides. The formula can get us right to this step right here. Okay, that's x equals 16. Okay, no decimals when you do a problem like that. All right, here it says find the value of x in each of the similar polygons. So they already told us they're similar. We're not checking if they're similar. Okay, so what we need to do is find x and find y. Okay, x, this side goes with this side of 9. So I know I need to have x over 9 if I'm going left to right. Okay, then I want to find a pair of sides that I have numbers for both. So a pair of corresponding sides where I know both numbers. One thing that would work is this 4 and this 6. Those are corresponding sides and I know the actual lengths of both of them. I don't have variables for those. So I could set this equal to 4 over 6. Okay, I could do the exact same thing to set up y. Y goes with this 12. So I could go y over 12 equals 4 over 6. And I could reduce the 4 over 6 if I wanted, but these are both solvable just by cross-multiplying and solving. Okay, so let's do that. Here I have 6x equals 9 times 4, which is 36. So x is 6. Here I have 6 times y equals 4 times 12, which is 48. So y is 8. Okay, next page. Same type of problem, okay, just solving for x, I guess is the missing directions there. Okay, this negative 4 plus 4x right here, okay, it actually goes with this 64, okay, the distance between j and k. So that's the first fraction I'm going to set up. I need something to set that equal to, so hopefully I have a pair of sides that correspond, and I know both of the numbers. I actually have two that I could use. I could use the 27 and 72. I'm going to use the 36 and the 96. And from here, I can cross multiply and I can solve. When I do that, I have to be careful with this. I got to make sure that I distribute 96 into negative 4 plus 4x. Okay, over here I have 64 times 36. I'll do that in the next step. Okay, like I said, distribute. So this is negative 384 plus 384 times x equal to 2,304 is the product of 64 and 36. Let's add 384 to both sides, and then we'll divide by 384 in our last step. Okay, 2,304 plus 384, that's 2,688. Okay, divide by 384. And we have that x is equal to 7. All right, the next one looks complicated, but it's not intended to be. Okay, if the scale factor of, and they give you a bunch of letters, A, B, C, D, E, F, G, to H, I, J, K, L, M, N, okay, if they're giving you the scale factor of 1 to the other, and it's 12 to 5, what if we reverse it? What if we go the second one back to the first one? All they're doing is flip-flopping the shapes, so we flip-flop the ratio, 5 to 12. Okay, angle E is congruent to blank. Well, angle E is in this spot, the fifth spot. 1, 2, 3, 4, the fifth spot here is L, so this is congruent to angle L. Okay, CD over JK, here's CD, here's JK, is equal to GA, that's the last letter and the first letter, so we need to do the same thing over here. Last letter is N, first number is H, or first letter is H. Okay. Let's see, determine whether the polygons are similar. If so, write a similarity statement and give the scale factor. Okay, one thing we'll need to do, we're going to go A, B, C, D. This one's going to be E, F, G, H. Okay, what we would need to check first, are all the corresponding angles equal? Okay, so are all the corresponding angles congruent? Okay, we have 4 pairs here, right? So we have a pair here that are marked. We have a pair here that are marked. We can go all the way around. All 4 of these have a buddy. So A is congruent to E, B is congruent to F, G is congruent to C, and E is congruent to H. So this is a yes. We got that. Okay, and then we check the sides. Are the sides proportional? Okay, sides need to be proportional, not equal, not congruent. Okay, that's what we're checking next. Okay, so then we're just checking the sides. We have a 5 and a 10 here. That would have to equal 2 over 4. That would have to equal 3 over 6. That would have to equal 1 over 2. And we just see, is that a true statement? And this is yes. Okay, this is true. So to answer the question, we need to do what they said, similarity statement. First thing for that is put the letters in order. A, B, C, D, squiggle, E, F, G, H. And then the scale factor from left to right is 1 to 2. Okay, next one, you can start to use some of the shortcuts. It says determine whether the triangles are similar. If so, state the theorem you use. So we have SSS, AA, or SAS. Okay, so in a problem like this, I have 2 pairs of sides, but I also have a bow tie, so I can use vertical angles here in the middle. So we would want to see if maybe this is SAS similarity. Okay, so we're gonna have to see if the sides are proportional, if they have the same proportion. So we would need 16, which goes with the 40. We would need 16 over 40 to be equal to, this one is also 16, and then this is 39. This is not true, okay? This is not true, does not equal, okay? So, since that's not true, these are not similar. Okay, if those proportions would have been the same, we would have been able to say yes by side angle side. Okay. All right. Last page here. So same idea. One though, I don't have anything to show me that any angles are congruent. So my only possibility is that maybe this is side similarity, and that's what I would be checking for. So you're trying to see if there's a common ratio between these. So the first thing we want to look at is one of the pairs of sides. So maybe 48 and 8. So this is 48 over 8. We want to see if that's equal to, pick another one, 72 over 12. Okay, and then see if that's equal to, pick the last one, 84 over 14. So we need to see if those are all the same ratio, and if they are, we're in good shape. We can say that this is true. So what's happening for each of these, 48 over 8 is the same as 6 over 1, 72 over 12 is 6 over 1, 84 over 14 is 6 over 1, so this one is true. Okay. So we're going to use side similarity, and we need to then put the letters in order. So if I call the first triangle ABC, squiggle. Okay, A is going to be similar with H. Okay, angle A is going to be congruent to H. Okay, angle B is going to be congruent to angle G, and then angle C is going to be congruent to angle F, and then we're doing bi, side, side, side. All right, next one, Aaron, who is 1.6 meters tall, casts a shadow that is 1.25 meters long, and you can see that in the picture. Okay, her shadow extends to the end of a tree shadow when she stands 4.75 meters from the tree. So we want to know what is the height of the tree. Okay, the first ratio, okay, we can use, so what we want is the height of the tree, so this can be our x, and that's going to go with this 1.6. So the first thing I would use is 1.6 over x, or you could have that flipped, x over 1.6 would also be fine. Okay, we need to set that equal to something. Okay, I started with Aaron, so I'm going to start with this distance as well. Aaron, the length of her shadow is 1.25, and then they did this a little bit funny. Okay, we need to use the length of the tree shadow. Okay, here to get this side of our triangle, we need that total length. So we have 4.75 and 1.25 that we're adding together. So this is a total length of 6, okay, for this triangle. So the length of the shadow plus her shadow, they're kind of back to back like that. All right, so that's what we're going to use. We're going to use 1.6 over x equal to 1.25 over 6, cross multiply. Okay, we get 6 times 1.6 gives us 9.6, and that's equal to 1.25x. Okay, we're dividing 9.6 by 1.25. And that gives us that the tree is 7.68. Our unit is meters tall. Okay, this one here says find the height of the giraffe in the diagram below. Okay, and we already have our two triangles here. Did not copy very well here, so this distance is supposed to be marked as 5 feet and 3 inches. So the person is going to be 5 feet 3 inches. Okay, this distance here is supposed to be 5 feet. Okay, this distance here is supposed to be 15 feet. So then, and then this is going to be our x. So it's a little bit hard to read. The first thing I would make a note of, 5 feet 3 inches. That's 5 point something. Okay, 3 inches. There's 12 inches in a foot, so 3 out of 12 is a quarter. So this is 5.25 feet. Okay, so 5 feet 3 inches. That's really 5.25 feet. Okay, that's something just to make a note of. Okay, so what we're looking to do then, set up a proportion. Okay, the height of the person is 5.25. The height of the giraffe is what we're interested in. Okay, the distance from the distance on the bottom of the triangles. I started with the person. The person's 5 feet away from the cage or the fence. Okay, and then the giraffe is 15 feet away from the fence. So this is what I'm going to cross multiply. We're doing 5 times x, and we're doing 5.25 times 15, which is 78.75. Okay, we're dividing that by 5, and the giraffe is 15.75 feet tall. If we wanted to put that back into inches, we could. Okay, that would be 9 inches. 15 feet, 9 inches. Okay, sorry, the picture didn't go in great. Hopefully it looks better on your copy. Okay, so this is the last page then. Okay, we have kind of leaking onto that last page too. So make sure you have these distinguished on your note card is what it says. Find the value of the variables for each of the similar figures provided. Remember, there are 4 kinds. Okay, so what we mean by plain ones, okay, is ones that look like the first one, okay, where there's nothing really special going on. Then we have kind of a few of each type here that we'll see. So a plain one, here's how you do a plain one. This is like number 1. Okay, this is a plain one. All you need to do is find x and then the side that goes with x. Okay, so this x is going to go with the 7. Okay, if you think about rotating the second triangle in your mind, then you got to pick a pair of sides that go together that you can use. So you could use this 6. Okay, the 6 is going to go with this 4. So one thing you could set up, 6 over 4 equal to, okay, 7 over x. I went left to right with the blues, 6 over 4. I have to go left to right with the rest. Okay, so with this one, I have 6x equal to 7 times 4, which is 28, and then 28 divided by 6. Okay, decimals happen. Doesn't mean that you messed anything up. This is 4.67. I'm going to skip this one for now. It has a little bit of an issue on it, so I'm just going to write C key. Okay, for when we get to when we put the PDF up there. All right, this one has parallel lines. Okay, when there's parallel lines, you can set this up a lot of different ways. Okay, so the parallel line coming through is breaking this up into some pieces that are proportional. So one way you can do it, okay, you can do the 9 over the 12. You can do the 9 over the x if you want. Okay, as long as these are parallel, you can look. You know that each side is getting split into proportional pieces. So one way you can do this problem is 9 over x, okay, equal to 12 over 14. Okay, or you could have the x and the 12 essentially flipped. You can do 9 over 12 or an x over 14, or you could have them flipped upside down. There's a lot of different ways you can solve this same type of problem, okay, but this is just one of those ways. We have 12x equal to 9 times 14, which is 126. Okay, and then we're dividing by 12, so x is going to be 10.5. Okay, and then the last problem, okay, same thing here. This is an angle bisector. Okay, it's splitting this into proportional sides. So you could do, one thing you could do is x over 13, okay, these two, equal to 9 over 10, which is these two. Okay, or you could do x over 9 equals 13 over 10, as long as you're going left to right, or consistent. So you can go top over bottom, or you can go left over right, as long as you are consistent with both fractions. So we have 10 times x, which is 10x. We have 9 times 13, which is 117. And we're dividing by 10. So x is going to be 11.7. And that's going to be it for this. Thanks for watching. Now go try the right-hand side.